Cool. Welcome to the Go Guild. We've got lots of announcements this month, so we'll get right to it. First of all, a massive thank you to everyone involved yesterday who came, who helped out, and the London Gophers for obviously coming here to visit Just Eat and Fleet Pace House. It was a really good event. Particularly shout outs to David and Maria who really helped us out on the event. But it was really good. I hope we can do more of them. And yeah, fantastic. Thank you very much. A big kind of moment in the Go space. Yeah, 124 arrives after I think 2 release candidates, and we've got some nice features that are here for you today. So yeah, you can install it from there. It's all out. Maps are, I didn't actually know this, maps are faster in 124. So one of the features that's been hidden, hidden from the feature set is the introduction of Swiss table-based map implementation. I had to look this up and I still really don't understand it, but hey ho. It makes for quicker map operations, and it was originally developed by Google, none other, and implemented in C++. So the idea is that it uses like enhanced metadata for key values, and it minimizes cache misses by storing metadata in those memory regions as well. So yeah, nice and fast maps, which is good. There's a t.context in testing. Now, this is really cool because the amount of times where you have to import context when you're testing, like context background, context to do, now you can just do t.context, which is really cool. So this returns a new context that has is cancelled just before cleanup is registered, or sorry, cleanup is called. And cleanup functions wait for any resources that shut down on context.done before the test or benchmark completes. So yeah, as I said, you don't really have to import that context.context all the time now, which is fantastic. Definitely going to be starting using this one. I read a blog post that indicates, Go's tool feature is one of the best additions to the ecosystem in years. And a reminder of what this does, it's kind of a new directive in go.mod where you can have this top right here, you can have tool. And that would be really good for, mocks. I think Uber mock uses that, or one of the mock libraries, you have to have like a tools.go file. So now you can just import them into your go.mod, which is really good. So yeah, good for depth for either user testing or generating code. You can put that in there. So something that's, I guess this is kind of like a, I mean, take this with a pinch of salt, but I guess it's kind of like a dev dependencies in your package.json. We could think of it, but yeah, really good. And that article is really good to look into. It gives a bit more detail in there. You can also add tool to when you're go getting something. So if you think it's just going to be for something that's just for like a development dependency, you can add that in there. WASM export, I think my colleague Tom mentioned this in the channel. We've got WASM export, a compiler directive into Go programs. So you can add Go WASM export hello, for example, and this exports functions to the WebAssembly host. There's a bit of docs there if you want to get involved there, and you can build it using that build command there. So that's specifically for WebAssembly. And now this is in 124. It's really interesting because we've got an example here. I'll go to that on the next slide. So you can see how we're importing it here. So there's actually a Go runtime within the standard library there. So you can just call WebAssembly, and that will load in hello and effectively just call hello. But really small amount of code for calling Go code within the front end. And I'm really looking forward to see some of the results that people do, or people do with this. So yeah, it's really cool. And it's just make it really easy for Go in WebAssembly now. Emit zero, I love this new feature. I think this is long time coming. I'll read what we get here. This is so people find that emit empty is quite confusing when working with nested structs. So when marshalling an empty nested struct, currently it marshals all of the child zero values. The emit empty option specifies that the field should be omitted from the encoding if the field has an empty value, defined as false, 0, or a nil pointer, etc., etc. So in the next slide, appreciate that there's quite a lot, but you can see type foo there. And the main thing to look at is time with emit 0. So we've got emit 0, and time.time is a struct, right? So we've got emit with empty as a time.time empty struct, and we marshal it, and you can see it outputs time with emit empty is putting the 0 value, but emit 0 is just completely not there, which is great. And that this kind of effectively means when you want something in JSON not to be there, you don't have to put a pointer, which is cool. And so many times I'm like, oh, I have to put this as a pointer because JSON needs it. But now we can go, okay, well, we can just do it as emit 0, and it doesn't need to be a pointer, but it's going to be emitted if it's empty value. I'd be interested to see what happens when this happens with like loads of nested structs, and like what are the captures with that. But I mean, really great feature, and I think definitely needed. Over to the community now, and what the community has been saying. V2 packages. This chap on Twitter or X really doesn't like the direction that Go is taking in with these V2 packages. So MathRan V2 has gone down well with the community, it seems. And I actually haven't used that, but yeah, anyway, people want more V2s of other packages. So sync is another one, and I don't know the specifics of what people wanted to do with sync, but it's kind of bringing back to the question is, how does Go manage breaking changes? Do we put V2 on the end of packages, or do we have a GoLang V2? Now, I don't think that it's going to be the latter, but how do we manage something like this? Do we want, and as he said here, quite rightly so, you know, encoding JSON V2, database SQL V3, I mean, it might become a bit messy. But yeah, interesting nonetheless. Yeah, and speaking of V2, there's an encoding JSON V2 proposal. So yeah, it's a really big proposal. These are really huge, but the idea is, I think, is to separate it out, this proposal. So JSON text is to handle the JSON grammar, while JSON V2 would handle maps and marshalling it to Go types. Within this proposal, there's also a new streaming API, finer control of JSON serialization with struct tags, no case, strict case, inline, unknown, and as well as emit 0 that we've just seen. Feel free to read it there if you've got 5. This is going to cause some controversy, and it's certainly got some thumbs up and thumbs down on the GitHub issue, but yeah, lines 1 to 4 on the right, we do this like so many times, right? I mean, if you look at a function, it's rarely that it's not in there. This proposal basically discusses the reducing of doing that and in favor of a question mark. So you can see on the bottom there, r : equal to semi-function question mark return error. So that question mark is replacing the error instantiation, and then if error equals nil. I immediately thought no, disgusting, but now looking at it, I don't know, I'm not sure. I'm still yet to be decided. I'm still yet to be convinced, but I'm sure you guys as well. I mean, yeah, it's just kind of like being quick for the sake of being quick. I don't know, but it's good. It's good for the questions there as well. I can see a lot of thumbs down in the chat. Have a look at the discussion. It's really funny. Similarly to that, that WASM export is that these guys replace React with Go and WebAssembly, which is really cool. I'm a big advocate for Go for front ends, and this is a really good step in the right direction, if you ask me. But a really interesting story nonetheless about how they kind of just replace stuff and how they went about it. So it's a good read. This was plastered over Reddit, and this person had an autoimmune disease, and they went to loads of different hospitals, loads of weird symptoms, and they had effectively spent hundreds of thousands of dollars trying to get diagnosed. So after 5 years, I mean, they decided to create a tool to try and help them diagnose, and the tool is called Open Health. So it's an AI tool that uses, leverages AI to analyze loads of medical records that he or she had, and it basically diagnosed them. It diagnosed them with this really rare autoimmune disease, which I just thought was astonishing. And these are the sort of packages that I think we can really get behind. It's just phenomenal that this sort of stuff is open source, that you're able to find out what's wrong with you, and the dashboard and the actual UI of this tool is really good as well. So please do have a look at it and support. It's a really great project. Something something I found on Reddit. What are some things you would change about Go? Does anyone have any ideas of what people might say in this thread? Feel free to put in the chat. I think two things came to mind from my side. But I mean, people really do throw their points out the crowd if they don't have some like features to go, and it is really a simple language. But any guesses? Well, one was well, nothing. Yeah, exactly. One was enums, which yeah, I mean maybe enum. I mean instead of doing like a IOTA kind of thing, which is cool. Remove new print and print line functions. Yeah, valid point. But yeah, and then null safety as well, or having like that option T we were discussing last time. So I think those three are quite good. But yeah, I'm interested to see what you think. Oh, and apologies, one more. Maps default to nil, so you wouldn't have to make a map. And I think this is caught us out on loads of separate occasions. Certainly caught me out on separate occasions. So yeah, I think that's a great feature of this. Some tips and tricks that I've discovered along my hunt for these slides. Go link name. So if you ever want to stub a function in testing, you can use go link name. So lines 9 to excuse me, bear with me a second. Yeah, so lines 9 to 11 there, we can see that we're stubbing time now to returning a set value. And you can see comment mark go link name time now with the standard library time now. And yeah, this makes it really cool for changing outputs in tests. So if you have something calling time.now, you can change it during the life cycle of that test, which is really cool. And then yeah, time.now will print whatever is on 11. The only drawback on this is it is a bit unsafe. So only best to use it when you really can't think of any other strategy. But I think it's kind of a neat trick. The other one is runtime set finalizer. So Go has a finalizer mechanism that allows you to run cleanup code when an object is garbage collected. So let me go through here. So first things first is we've got a cleanup function that takes a resource. The resource just has an ID. And then we set finalizer here and pass in our cleanup function and pass in a pointer to a resource. This could be anything. We call garbage collection and then give some time for GC to run, and you can see exactly what happens there, and the cleanup function gets called. Use cases for this, debugging and logging cleanup events. Perhaps when a resource is released, when you think you need to release a resource, or it might be useful to see locally when something is being cleaned up, a large struct, something like that. And yeah, a failsafe for resource cleanup. So if a dev forgets to call close, like on a file, it can be used as a safety net, which is really cool. I can see this in conjunction with like defer, like a defer or something like that. But there's a really good article there, but quite interesting. And some tools that I've discovered along the way. So Whales. So this allows you to build desktop apps using Go and web technologies. It kind of allows you to wrap Go and front-end code in one binary. It's available there. You can see a little code snippet on the right there. We can embed front-end disks using Go embed, front-end assets and stuff. We can create a new app there. We can do Whales.run and pass in a width and a height, and that will bring up a window, which is really cool. And we can pass it start up, shut down things and stuff like that. So can't wait to see like the more front end tools or GUI tools are built with Go, but this is a really cool package. Zog validation. I've forgotten the kind of JSON equivalent. I think is it Zod, but yeah, Zod validation. I think this is kind of a Zod validation for Go. I actually haven't seen this before the last couple of weeks, but it's really powerful. It looks really powerful. Yeah, schema builder for runtime value passing and validation. It's kind of for really complex models, and it's also got built-in env HTTP, JSON, and international parsing. Here's a small example here. Got a user schema, so you can validate the struct. You pass in a z.schema. I like the fact that you can pass in like a message as well, as opposed to like going configuring it elsewhere. So it's all there, and then you kind of just validate it. And yeah, as I said, you can pass in a HTTP request and pass in the user, make sure it conforms to that struct, or you can use env vars, which is really cool as well. But I think really wide use case there, and I'm sure there's other validation libraries that people use, but this is looked quite a good one. SVG Go, if you're that way inclined, if you want to build your new front end in Go, you can generate shapes and lines, whatever to your heart contents in SVG Go. So that's native SVG drawing, I should say, in Go. So lines, text paths, gradients, transformations, and much, much more. So over to our knowledge share. So Gregory has been with us in the Jet Connect Groceries team for, I think it's maybe 4 or 5 months. Correct me if I'm wrong, Gregory, but yeah, you've been a bit of a force coming in, and yeah, really great. So he's had 3 years experience in Go, 2 years working at a telecom company, and a 1 year dynamic startup environment. I think Gregory, yeah, great fit in the team, and I really can't wait for your talk. So over to you, mate. I'll stop the screen share now.
Yeah, thank you, Ainsley. Can you see my screen? Yeah, nice. So, yeah, I'm passionate about Go, and today's presentation is titled Inside the Go Scheduler, Preemptive Multitasking. Go is a popular language thanks to lightweight concurrency model, which makes it easy to run thousands of tasks concurrently. The key element that makes this possible is the Go routine. But how does it work under the hood? On average, PC, server, or virtual machine might have, let's say, up to 32 CPU cores, meaning only 32 Go routines can execute in parallel. So if we run 1000 Go routines, what happens to the other 964 Go routines? The answer is concurrency. It allows multiple Go routines to run on each CPU by switching between them. In Go, the scheduler is responsible for managing this process. You can find the scheduler's implementation in the Go source code on the link below, but here is a simplified breakdown. First, we have P, processor, which represents a real CPU core. Then we have M, machine, which represents an OS thread. And then we have G, Go routine itself. And each CPU core runs the local queue of Go routines associated with its processor, executing only one at a time and switching between them. Great, but how exactly does the switching occur? The answer is simple. Starting from Go 1.14, the Go scheduler became preemptive, while in earlier versions it was cooperative. When I tried to understand what that really means, I quickly realized that this topic is rarely covered in depth. So I decided to dig deeper to see how it's implemented. Before we start, I want to mention a few videos that inspired me. They provide an excellent explanation of how the Go runtime works under the hood. I won't go into too much detail about the entire runtime architecture. You can check videos I mentioned, they are great. Instead, I'll focus specifically on how preemptive and cooperative multitasking work in Go. Disclaimer, I was not involved in the development of Go. Everything I share with you is based on self-learning. So there are two ways to implement scheduler multitasking, preemptive and cooperative. In preemptive multitasking, switching occurs through the scheduler's intervention. In cooperative multitasking, task switching occurs only when the current running task explicitly yields control to another task. While this model is simple to implement, it has a drawback. One selfish task can block or slow down the entire system if it doesn't release the processor. And it seems like a real problem. And it's important to mention that just 5 years ago, Go was cooperative. The only relevant information I found was in the Go 1.14 release notes, the version where preemptive multitasking was implemented. The interesting detail caught my attention. Loops without function calls could potentially deadlock the scheduler. To see this in action, I wrote a small program and ran it on Go 1.13 before synchronous preemption was introduced. Let's break down our code step by step. First, in the main, I artificially limited the number of processors to 1 using runtime.goMaxProc. When I created a function called infinite loop, which runs an infinite loop without making any function calls. After that, I launched infinite loop as a coroutine. Next, I started another coroutine, just run it in the background, and gave them some time to execute for 3 seconds. I didn't use channels or wait groups for synchronization, where there was no need in this specific example. Now, what happens? In the latest version of Go, everything works fine. The program runs, both coroutines get execution time, and it exits successfully. But when I ran it on Go 1.13, something different happened. Go routine 2 starts, when Go routine 1 starts, and then nothing. The system is effectively stuck. The reason? The Go routine 1 has no function calls, which means there are no natural yielding points. Since the Go scheduler was cooperative back then, this selfish Go routine completely takes over the only CPU core, and it prevents any other Go routine from running. So, just to clarify, before Go 1.14, without asynchronous preemption, a Go routine could only yield control via explicit calls to runtime.ghost. A function calls, it's actually implemented at the assembly level in so-called function prologue and blocking operations. So if you insert any function call into an infinite loop, like I just did with fmt.sprint, it introduces a save point where the scheduler can check and yield control, effectively resolving the problem of the Go routine monopolizing the whole CPU. Who would seriously write an infinite loop that does nothing? Jan Lance Taylor, who has been involved with the Go project, said in one of the GitHub issues that it was never considered a real problem. So there was probably another reason. Let's dig deeper and have a look at the actual proposal in GitHub. There is a link if you want to check it, and it says next. The most common in production code is that this can delay STV or stop the world operations, such as starting and ending a GC garbage collector cycle. This increases stop the world latency, and on large core counts can significantly impact throughput. What are STV and GC? GC is a garbage collector. In languages like C++, memory management is manual. You allocate memory with well-known function malloc and free it with function free. While it allows developer improve memory management, it also increases development complexity. In Go, developers don't need to manage memory manually. The garbage collector handles it automatically. Stop the world means stop the world. So Go's garbage collector uses a tricolor mark and sweep algorithm. I won't go too deep into the details. One of its stages is initialization, where the GC must pause all runtime activity to identify unnecessary objects. During this stage, all Go routines stop, meaning program stop. Under normal conditions, this pause lasts only nanoseconds. Now that we understand this, let's examine what the proposal meant by the most common issue in production code is that this can delay stop-the-world operations. To illustrate that, I wrote some code. The program follows a simple structure. First, we have channel initialization, nothing serious, just create 2 channels. Then we have a loop which launches 4 Go routines executing the worker function. Worker is essentially a function that rapidly fills the heap or memory, triggering frequent garbage collections, including stop-the-world pauses. I'll remind you that these pauses are stages where the program completely stops. You can check full function implementations of worker in the link below. Next, we launch complex operation Go routine. Complex operation is a function that performs intensive arithmetic calculations but has no function calls, meaning no yielding points. and this function can take up to 2 seconds to complete. At last, wait to finish, a function which ensures all Go routines complete execution. Now let's look at the execution results on the different Go versions. When running the program on the latest Go version, everything works smoothly. The ping G2 Go routine, which is a complex function, gets efficiently ping-ponged between processors, and the heap usage forms a wave pattern, showing that memory-intensive tasks are rapidly filling the heap, and the garbage collector cleaning the heap on every stage. And execution time is around 2 seconds, and max top-the-world duration 10 nanoseconds. Everything looks stable and optimized. However, when running the same code on Go 1.13, we observe almost doubled execution time and a strange stop-the-world pause lasting nearly 2 seconds. I'll remind you that stop the world means the entire program stops. And as a result, you can see that both procs 0 and procs 1 do not execute any Go routines. Yeah, meanwhile, on previous example, there's always some executions. Why does this happen? The problem is with the complex operation function. Since it contains no yielding points, it completely occupies processor. And when the garbage collector requests a stop the world event, all Go routines must pause. However, it cannot stop complex operation until it completes, meaning all other Go routines remain blocked for nearly 2 seconds. Now you might say, in production, no one is going to run complex arithmetic operations like Fibonacci calculation on a live server handling 200 users. But the issue remains relevant in scenarios like cryptographic operations, for example, encryption, hashing. Even if such operation takes 200 milliseconds instead of 2 seconds, it still delays stop-the-world pauses significantly, from nanoseconds to milliseconds, ultimately hurting program performance. Yeah, or even database insert, definitely. This problem was one of the main reasons Go introduced asynchronous preemption in version Go 1.14. To fix this, first we retained cooperative preemption, but implemented asynchronous preemption, which is handled by a special internal process called sysmon. Sysmon was existing continuous background process in the Go runtime, already responsible for the several tasks, including sweeper, it frees unused memory pages, scavenger, releases memory back to the OS when possible, and others. It runs every 10 milliseconds, checking for Go routines that have been running for too long, and interrupts them if necessary. So first of all, let's start at the very beginning, the entry point of any Go program. Now you might think it's just the main function you wrote, but in reality, everything begins in assembly language. This entry point depends on your operating system and architecture. You can see examples for Mac, Linux, and Windows. Once the initial setup in assembly is done, it calls the main function from procs.go. But here is the catch. It isn't the main function you wrote. In the runtime, it's main. And as you can see in source code, it's empty. And by the way, it also uses GoLang name. It's a tool Ainsley mentioned in his presentation. So obviously it gets linked at the assembly level during the compilation stage. So what does this runtime main actually do? Let's break it down. First, it retrieves the current Go routine using getG, then accesses its associated machine, M, which represents an OS thread. Next, it calls sysmon. We will dig deeper into it later. After that, we enable garbage collection by calling gsenable. And finally, after all these steps, we launch our actual main function, the one we as developers wrote. Let's dig into the sysmon. As I mentioned before, it runs every 10 milliseconds, but at the beginning of the at the program, it runs more often. You can see it goes from 12 nanoseconds up to 10 milliseconds. When we have some code related to netball and the scavenger, I just commented it out because it's huge. You can see the full version on the link below if you're interested. And after that, we have function retake. The main job of this function is to check every P or processor in our system and see if any Go routine has been running for more than 10 milliseconds. Retake loops through each processor using all P. Processors are stored in slice called all P, and it's literally a slice of registered P or processors. On each loop iteration, it checks if any Go routine has been running for more than 10 milliseconds. You can see constant force preempt ns that is set to 10 milliseconds. When in the else if condition, you can see it compares pd.shed plus 10 milliseconds with now, and which means the Go routine has been running for more than 10 milliseconds. If this condition is met, it calls the function preempt1. This function preempt1 checks the Boolean variable preempt_m supported, which is true on almost all architectures. However, it can be false, for example, on unsupported or legacy architectures. Preempt1 also validates debug.async_preempt_off, which is used to disable asynchronous preemption for debugging purposes. This means you can disable it even on the latest version of Go. So if you want to experiment with it, you don't have to install an older version of Go. Finally, this function calls preempt_m. The main job of preempt_m is to send a signal notifying the OS that it needs to preempt a Go routine. Its implementation varies slightly depending on the architecture. Here you can see it calls the function signal_m, which notifies m or the OS thread and send a special sig_urg signal. What that is, I'll explain later. When obviously we need to handle this signal, and a signal handler is responsible for that. It lives on each M or on each OS thread, and its job is to determine whether the currently executing Go routine can be preempted. If it can, we save its current state, registers and stack state, and allocate resources to another Go routine. Otherwise, the execution of the current Go routine continues. This handler is already responsible for handling Unix signals like sigprof, sigkill, sigterm, etc. So for example, if you terminate the program with sigkill or sigterm, this handler will manage it. So when it receives the sig_urg signal, it then calls the function doSigPreempt. The function doSigPreempt mainly performs two checks. First, won't_async preempt checks whether G wants to be preempted. Second is async savePoint, checks whether preemption can happen right now. The most interesting check here is whether G is at safe or unsafe point. Additionally, we need to ensure that the thread executing G is also ready for G's preemption. Async preempt is implemented in assembly, but ultimately it preempts the Go routine from running on the processor, allowing the Go scheduler to regain control. And that's pretty much it. Well, we covered how cooperative and preemptive multitasking work in Go, broke down some examples, and took a closer look at the Go scheduler. In conclusion, I would advise always relying on the latest version of documentation. A few years ago, during one of job interviews, I said that Go is a cooperative language because I read an outdated article from 2020. Don't repeat my mistakes. So yeah, asynchronous preemption in Go is great. I uploaded to the GitHub repo. I uploaded examples to the GitHub repo in the link below. You can check them out if you want. Feel free to ask any questions.
That was an amazing talk. That was absolutely fantastic, Gregory. Thank you so much. Yeah, I wanted to ask. I mean, I'll kick off the questions if you don't mind. I mean, how do you kind of start and go into the Go runtime, and how do you kind of research these things in a way that is kind of easier for you to understand? Because sometimes I feel like I go into the runtime and it is like, whoa, there's a lot there. So yeah, I just want to ask you that really.
Yeah, sure. So as I mentioned before, I was inspired by a few videos, and especially I was inspired by first video, understanding the Go runtime. Jesus Espino, he also did a presentation for Gophers Go UK Gophers Confederation,
Okay.
and it's really helped me to understand like the entire runtime architecture. But yeah, what I did is that I covered specific aspect of cooperative and preemptive multitasking, but he covered the entire Go runtime, and it really helped me to understand. And
I think. Yeah. Thank you very much. Does anyone have any questions for Gregory? All good. Well, thank you so much. Let me reshare my slides if I can. My keyboard isn't working. There you go. So the only other thing in the guild this month is if you could take our survey. I'll put it in the channel. We'll take literally 5 minutes. We'd really appreciate it. We want these talks and this guild to be as useful as possible for you. So we'd really appreciate just 5 minutes of your time just filling out a form there. But apart from that, unless anyone has anything else to raise. Yes, David, after you.
Did you post that in the organizer channel instead of the main channel?
I posted it in the organizer one and I realized I sent the wrong one to you guys, and I'm sending it to you the right one now. And I'll send it in the main channel as well.
Awesome. Thanks.
Perfect. Cool. We'll wrap up there. Thank you very much for attending, guys, and have a lovely afternoon. Appreciate it.